with 7.6 and we're skipping 7.5. That is no longer part of the requirements for this course, so we're going to skip over that. Going to review just a minute here. This is going to come back to talk to us a little bit, but we know the small number is the exponent. We have the variable, and the large number in front is a coefficient. There's a lot of terminology as we start talking about polynomials, and the first is to understand what a polynomial is, and it's a sum and difference, the addition and subtraction of a monomial. Well, that doesn't really help me a whole lot because I don't know what a monomial is. But a monomial is a number or constant a letter, which we call a variable, or a product, which means we're multiplying, a constant and a variable. The key is it has to have a whole number exponent. And whole numbers are the counting numbers plus 0. 1, 2, 3, 4, 5 plus 0. Here are some examples of a monomial. A number, positive or negative, a variable with an exponent. Here we have a coefficient in front of, and it again is the product of numbers and letters, constants and variables. And we can even have a fraction coefficient. The other thing that I always want to point out to you is, even though it's not written, we do have an exponent of 1 here and here. So those fit the requirement of the definition of having a whole number as an exponent. Now, things that are not exponent or not a term or a monomial, this is not, because it's not a whole number exponent. This is multiplication, but it does not have an exponent with it. And here we have x in the denominator, which we know that would be also written as 5x to the negative 1 if we moved it across the fraction bar, and this is not a whole number. It is an integer. It is not a whole number. So it allows us some time there to look at that. Now, the other thing is here, I just kind of threw it in here, a monomial or term. Those are interchangeable terms, interchangeable words, meaning to describe a number, a variable, or a product of numbers and variables. The degree of a monomial is important to us, and we find that by adding the exponents of the variables of a term. So here are 3 examples, and the degree here only on the variables, that's a 3rd degree. We add these 2 because they are the exponents on the variables. This is a 5th degree. Here again, I continually bring it up to you because it becomes a stumbling block. There is a 1 there, so this is a 1st degree. Now here are 3 or 4, actually 4 examples for you, but I want you to try and identify the degree. So we have found those degrees of those 4 terms, and we'll move on. Now we talk about the degree of the polynomial, where we have more than one term. We just found the degree of single terms, and now we're going to find the degree of a polynomial. Well, the degree of the polynomial is equal to the term of the highest degree. So whatever is the highest degree is the degree of the polynomial. And there are some reasons why that is the case, and we're going to talk about the different degrees and their names. And I'm just going to talk about this part first. If it is 0 degree, it's constant. And a constant we talked about before is like a number 5. Linear, if it's the first degree, that means its highest exponent is 1. Between the two terms here, the highest degree is 1, so that's the degree of the polynomial. The same would be true here. For a degree of 2, that's called a quadratic. As I compare these terms, this is second degree, this is first degree, this is 0 degree, this constant. So the highest degree here is 2, so the degree of the polynomial is 2, and that is a quadratic. Cubic, degree of 3. Highest exponent is 3, the sum of exponents is 3, this is exponent of 0. An exponent of 4, highest exponent of 4 is a quartic, like a quarter, like 4 quarters in a dollar, 4 quarts in a gallon. Here it's 4, here it's 2, here it's 0. And if I have a degree of 5, it's called quintic. So 0 degree is constant, we know something about the equation. Third degree is cubic, we know something about the equation. Now that's not the only thing we know. And that's why classifying by degree is so important. The graph of a constant is a number on a number line. The graph of something with an exponent of 1 is a line. We've worked y equals mx plus b. We know that is the equation of a line. We talked briefly a couple of weeks ago about an x squared being the shape of a parabola, and that parabola being a function. And the best example for us was the wake at the back of a boat. Cubic looks like a snake.
Hey, you might want to take some notes.
Y equals x cubed minus 27 is the shape of a snake. And again, each of these degrees has a specific shape when we go to graphing it. If it's a 4th degree, it's got like a little mountain here, upside down McDonald's sign, whatever. Even the 5th has its own shape. Now again, I'm going to ask you to classify each of these by the number of degrees. Okay, as you do these, you're looking at each term now. This is a degree of 3, this is a degree of 1, this is a degree of 0. The highest degree here is 3 amongst the 3 terms. And these terms are separated by addition and subtraction signs. So I have 3 places to look here. 3 is the highest degree of any one of these terms, so it's the degree of the polynomial. and therefore it is identified as cubic. Here I have an exponent of 1 and an exponent of 0. 1 is the highest degree between the two, so that is the degree of the polynomial. First degree is linear. Do not tell me third degree and first degree. You must use cubic and linear. Here I have, again, x squared and x to the 0. X squared, or degree of 2, is the higher of the two terms. Therefore, this is a quadratic. And finally, I have negative 11. Again, with the degree of 0 is the highest degree and the only degree, so therefore, this is a constant. All right? So, moving forward, we also classify polynomials according to the number of terms, or monomials. Remember, these are the same thing. It's a constant, it's a variable, or product of a constant and variable with whole number exponents. Examples of those with one term: a number, a product of a variable and a number, and that having a whole number exponent. These are separated by addition and subtraction signs. This has two terms because the subtraction sign in between the 3x and the 1 separates those two terms and makes it each apart from one another. Three terms, again, here is 1, separated by a minus sign for 7x, separated sign by a 9. Like above, where the degrees have specific names, the number of terms has specific names as well. They are part of polynomials. The nomial part repeats. Mono, monotone, someone who speaks at the same level, same pitch all the way through and doesn't change anything. One term, one voice level. 5 is a variable, a product, and 7x is a constant, a variable, and a product of a constant and variable. The binomial has two terms, like bicycle, meaning two. Two terms, separated by an addition sign here, separated by subtraction sign over there. Trinomial, triangle, tricycle, meaning three terms. Again, separated by addition and subtraction signs here, and two subtraction signs over here. Classifying by the number of terms. Now, after that, monomial, binomial, trinomial, we don't get real scientific. It's 4-term polynomial, 5-term polynomial, but again, all of this is separated by addition and subtraction signs, and we're able to count them So now I'm going to again ask you, or show you some examples actually, to classify each by the number of terms. And again, these are separated by addition and subtraction signs. So there's 1, 2, 3 terms here, This is a trinomial. There is only one term here. This is a negative in front that goes with the 7. So this is a monomial. And again, don't tell me 1, 2, 3 terms. You've got to use the words that identify them, the labels. Here's a subtraction sign separating 5x and 1. So this is a binomial. And here we have several being separated. 1, 2, 3, 4. There is no fancy dancy word up here. This is simply a 4-term polynomial. A 4-term polynomial. Now, one other thing I just kind of glazed over there, I want to make sure you understand, is the sign in front of the number or the term goes with it. This is a -7. That negative goes with that 7. If we had to break this down, 5x and -1, this would be a -1. That sign goes with it. Okay? So classifying by the number of terms and the degree help us with graphing. Now when we get into factoring, this number of terms thing is going to be really important to us. We're not there yet. Won't be there for probably another few weeks, but we'll get there this year, I promise. Okay? Got to be able to classify them as by degree and by the number of terms. And that's exactly what I want you to try right here. You're going to try to do both. Okay? Here are 3 examples for you to classify each polynomial by degree as well as the number of terms. All right, so we want to classify these by degree first. Third degree, first degree, 0 degree. So this is a cubic. And there's 1, 2, 3 terms. So this is a cubic trinomial. Degree of 2 and a degree of 0. So the degree of the polynomial is 2, which is quadratic. Binomial. Here we have a degree of 4, a degree of 3, a degree of 1, and a degree of 0. So the degree of the polynomial is 4. So that is a quartic. And we don't have a fancy dancy name for 1, 2, 3, 4 terms. So this is a quartic 4-term polynomial. Quartic 4-term polynomial. Now it's been very nice and neat and easy for you because I've organized the data for you and wrote it in what we call standard form. Standard form of a polynomial with one variable, they must be arranged so that the term of the highest degree is first and remaining terms are ranked in order. And what that means is this. Here is the polynomial, but I have to rank it and put the terms in order from greatest to least. And with this comes what point I made, that point I made just a minute ago, is that the sign in front of the coefficient goes with it. This is the highest degree. So my first term is positive 4x to the 5th. The next highest is a degree of 4, and that is negative 11x to the 4th. No sign in front. If it were negative, there'd be a negative sign there, but there's not. So it's understood that this is a positive. So positive 8x cubed would be next. Then we go to the square. Then we go to the degree of 1. and then we go to the degree of 0. So this would be rewriting that in standard form. Final answer, as you can see, has the exponents going from greatest to least. That ordering is called ranking, and it's required to put things in standard form. Final answers will always be in standard form. When we get to adding, subtracting, multiplying, and dividing this stuff, we will put it in standard form. This is of the 5th degree, so it would be also called quintic. 1, 2, 3, 4, 5, 6 terms. It's a quintic 6-term polynomial. That's how you would identify that. I'm going to give you a minute to get this down. Leading coefficient is a coefficient of the first term in a polynomial that's written in standard form. Here, this is written in standard form. 4 is the first coefficient in the polynomial as it's written in standard form, so it's the leading coefficient. Here's another example written in standard form. The first term is 7x squared. That leading coefficient is 7. The problem of the day is this. It summarizes everything that we've done so far. Write the polynomial in standard form. State its degree. Classify it by the number of terms, and then identify the leading coefficient. Go. Questions here? Okay, you have about 15 minutes left. I do have an assignment for you that you can get started on. It will be posted sometime during Pathways, maybe in 15 minutes. Don't put your notes away. You may need those to refer to. Here is that homework. Give you the first 17 problems there.